Hello students, how are you all? Welcome Akshar online classes, IIT foundation classes, and I am your chemistry faculty S. Mohan. Students, in the last class we were doing the normality and concentration of solutions. In that previous topic we completed normality, molarity, mole fraction and so on, right? So today let's solve some exercise, right students? So before going to the exercise, once it's better to revise the formulas. What is molarity, what is molality, what is normality, what is mole fraction, okay? So first molarity, come on, can you define molarity? Number of moles of solute present in 1 liter of solution. Very good. So formulas are very important. If we know the formula, then only we can able to do the numericals or problems. Okay. So molarity is what? The number of moles of solute present in 1 liter of solution. Very good. Then come to the molality. What is molality? Same, just a small change. The number of moles of solute present in 1 kg of a solvent. 1 kg of a solvent, right? Next, come to the normality. The number of gram equivalents of a solute, the number of gram equivalents of a solute present in 1 liter of solution is called normality, right? And last one is what? Mole fraction. What is mole fraction? The ratio of number of moles of solute or solvent to the total number of moles of solution is called the mole fraction, right? So good. So this I give the formulas also to you. So these formulas you have to learn, okay? And then we need to solve the problems. Alright students? Chalo. So today, okay. So in the previous class we discussed up to mole fraction. Now if you have a material, once you open the material, page number 19, then we have some practice sheet is there, right? Practice sheet. So just if you have a notebook or pen, open, and what I'm explaining, first you concentrate and try to do it. Okay. So 1 molar solution is one that contains. 1 molar solution is one that contains. So molar means what? Molarity. Okay. So now based on this, here 4 options are given. Now you can select one of the option. 1 gram solute of in 1000 grams of solvent. 1000 grams of solvent. What it is? Molality. The number of moles of solute present in 1 kg of a solvent. Okay. So that is molality. So no, that is not right answer. 1 gram mole of solute present in 100 ml of solution, because generally we take 1 liter of solution. So that's also not. 1 gram mole of solute in 1000 liter of solution. No, that is also no. 1 gram mole of solute in 1000 grams of solvent. So see students, here actually the no option is there. So the third option, what is there? 1 gram mole of solute in 1 liter of solution should be there. Okay, so that is the right answer, right? Now then come to the unit of mole fractions or mole fraction, the ratio of number of moles of solute or solvent to the number of moles of solution, right? Ratio, this is ratio, remember, ratio. Now the unit of mole fraction are moles per liter, moles per ml, no units, gram equivalent by kg. Come on, ratio of number of moles of solute by number of moles of solution. Good. So the answer is no units, because here this is a ratio. Ratio means what? Fraction. So in the numerator also you have the number of moles, denominator also number of moles, so that get cancelled. So hence there are no units for mole fraction, right? Very good. Then come to the next one, 0.1 gram mole of urea. 0.1 gram mole of urea is present or is dissolved in 100 grams of water. In 100 grams of water, then what is the molality of the solution? Okay. So here molality. What is the molality formula? Is equal to number of gram moles of solute. I'll write number of moles of solute. Okay, by 1 kg of solvent. This is a formula, right? So number of moles in the place of number of moles, what is given? 0.1 is given. 0.1. But here it is, what is given here? 100 grams of water is given. 100 grams of water. 100 grams of water you convert into kgs. So 100 grams of water, how can you convert? 100 grams divided by 1 kg. 1 kg is equal to what? 1000, right? So 2 zeros get cancelled, left 1 by 10. So that is equal to 0.1 kg. Yes or no? 100 grams is equal to 0.1 kg, because 1 kg is equal to 1000 grams, but we are 100 grams only. So 100 grams is equal to 1 by, okay, 1 by 10. That's called 0.1 kg, right? So now what happens? Divided by, so 0.1, right? So 0.1, 0.1 get cancelled. So left answer is what? 1. So therefore the answer is 1. Okay, 1 molal. Okay, 1 molality. So option is what? 0.1, 0.01, 0.0014. Fourth option is the right answer, students. Did you understand? Okay, once check and do in your notebook if it is possible. Molality is equal to number of moles of solute by 1 kg of solvent. Yeah, number of moles, no problem, that's given 0.1, but 1 kg of solvent. So here, but it is given in the problem 100 grams of water only given. 100 grams of water is given, right? So we have to convert 100 grams into kgs. So then this becomes 100 by 1000, that's equal to 1 by 10 is equal to 0.1 kg. So 0.1 by 0.1, that's equal to 1. Clear? So option is fourth option, right? Chal. Let's go to next one. 60 grams of urea is dissolved in 90 grams of water. Then what is the mole fraction of solute? Okay. So now let us see here what is given here. 60 grams of urea. Fifth question. 60 grams of urea. Okay. Where it is dissolved in 90 grams of water. Okay. Now what they are asking to find the mole fraction of solute is mole fraction of solute is how much, right? So first for this what you need to do, you need to remember the formula of mole fraction. Mole fraction is equal to number of moles of solute by number of moles of solution, right? So see, a mole fraction is denoted by chi. It is called, looks like a x I told you, okay? Chi of solute is equal to number of moles of solute by Na. Number of moles of solution is solute plus solvent, that is Nb. Okay, this is. But number of moles are not given here. Grams is given, students. So you have to convert these grams into number of moles. How can you convert? So in the last class I explained you that mole formula is weight by molecular weight. Weight by molecular weight. This is the formula. Okay. So you are in 9th class. This topic is there for you, mole concept. in the third chapter, atoms and molecules. If you can check once in your textbook, this concept is there, mole concept. Okay, so there we have a how to calculate the mole. It is there once you check. Okay, so now mole is equal to, okay, I want the mole of number of moles of urea. Okay, so urea formula is NH2CO NH2. You have to remember this one. Urea formula is what? NH2CO NH2. So here nitrogen, N stands for nitrogen, atomic weight is 14, and hydrogen atomic weight is 1. 2 hydrogens are there, so 2 ones are 2, plus 1 carbon, carbon atomic weight is 12, so write 12 only, plus 1 oxygen, oxygen atomic weight is 16, so write mass number 16. Next nitrogen again, nitrogen mass number is 14, so write 14. Next 2 hydrogens are there, hydrogen atomic mass is 1, so 1 2s are 2. Chalo. Now this all you should add so that you will get the molecular weight. Okay, this one you will get molecular weight. Okay, so molecular weight will get. Did you understand how to get the molecular weight? Very simple. If you know the atomic masses, then just you add all the elements atomic masses. So urea formula is what? NH2CO NH2. So we are taking the atomic masses of all these, just we are adding. Nitrogen atomic mass is 14, hydrogen atomic mass is 1, but 2 hydrogens are there, so 2 ones are 2, and 1 carbon, carbon atomic mass is 12, oxygen atomic mass is 16, nitrogen atomic mass is 14, and hydrogen atomic mass is 1, 1 2s are 2. Now chalo total how much it is? Count. Count it. How much? You got 60 here. You should get 60. Once you check now, 14 plus 2, 16. 16 plus 12, 28. 28 plus 2 here, 30. 30 plus these two, 30. Yeah, 60. Okay. So, did you understand? So, 30. Chalo. So, we got total 60 molecular weight. Now, weight is how much it is given? Weight is equals to 60 grams of urea. So, write here 60 divided by, now molecular weight. Molecular weight is got how much we got? 60. So, 60, 60 cancel 1. So, Na I got 1. So, Xa is equal to, in the Na place I will write 1. Clear? Now what I want? Now I want this number of moles of water also I want, because that is dissolved in 90 grams of water. So, I want number of moles of water. So, number of moles of water I calculate in the next slide. How many grams of water is there? 90 grams of water. Okay. So, under the same formula, number of moles is equal to weight of substance by its molecular weight. This is the formula. Now, water formula, what is the formula of water? Good, H2O. So, water formula is H2O. Now, let us find the molecular weight. Molecular weight of water. How many hydrogens are there? 2 hydrogens. Each hydrogen atomic mass is how much? 1. So, 1 2 is a 2. Plus how many oxygens are there? 1. What is the oxygen atomic mass? 16. 1 6. Right? So, 16. 2 plus 16 is equal to how much? 18. So, molecular weight is 18. Right? Now, formula is what? Number of moles is equal to weight by molecular weight. Weight, how much it is given in the problem? 90 grams is given. Check there. Okay, 90 grams is given. So, see here, 90 grams is given. Right? 90 grams. Now, molecular weight is how much? 18. 18. So, cancel 18 ones are 18 5s are. So, what I am getting? Number of moles of water? 5. So, that is NB. NB is equal to 5. Right? So, now where is NB? So, Na plus NB. Na I already got, that is 1. So, 1 plus NB I got 5. So, that is equal to 1 by 6. That is all. So, is there option? Yes. Now, see the second option. Second option is 1 by 6. Is this understood to you? Yes or no? Nothing, very simple, very easy, only simple calculations are there. You need to memorize like what are atomic weights of the elements, and of course urea, the formulas, some formulas are okay. You learn in the, when you practice the chemistry continuously, this type of so many formulas, chemical compounds and their formulas will come. Practice makes you very, very perfect, right students, right? So here what to be remember you is, you need to remember what are the things to be remember here today. So first you remember the formula of urea. This is urea formula. Somewhere you'll get in the next one. And this is the number of moles, how to calculate molecular weight by molecular weight. And this is the formula of mole fraction, right? So these three you need to remember. Clear? So once you check it out, if you have any doubt, once again if you want me to explain, I'll explain, don't worry. So if you can post in the chat box if you don't understand. Okay. So see now, question is what? 60 grams of urea is dissolved in 90 grams of water. Mole fraction of solute we want, right? So here urea 60 grams, I have to, for mole fraction formula, number of moles of solute by number of moles of solution. This is the formula, Na by Na plus Nb. Na is a mole fraction, number of moles of solute, means urea you take, and Na and Nb you can take the number of moles of water. Okay, so this can be calculated by using this formula. So in this way, right? Chalo. Now let's go to the next sum. Next sum. This is a theoretical sum. Okay. The concentration units which depends on temperature would be, yeah, this also, while explaining the previous classes, I said you that some concentrations will be independent of the temperature and some concentrations will be depend on the temperature. Now, what they are asking to find which depends on the temperature, that is normality. Direct question. Okay, that is normality. The concentration units which depends on the temperature will be normality. Okay. Chalo, next go to the next question. The number of moles of KCl, that is called potassium chloride, in 1000 ml of water of 3 molar solution. Students, their normal is printed, that is 3 molar solution is. 3 molar solution is. Okay. So let us see that question. I'll write the question, 8th one. The number of moles of potassium chloride. The number of moles of potassium chloride, that is KCl. Okay, KCl in 1000 ml of water. 1000 ml of water of 3 molar solution. So students, here it is very simple. Number of moles is given, that is N is equal to, we need to find, okay, in 1000 ml of 1000 ml. So here volume is given, that is 1000 ml, and 3 molar is given, molarity is equal to 3, right? So this is our formula. The formula is what for molarity? Molarity is equal to number of moles of solute by volume of solution in liters, right? So M is equal to 3, so write 3 here. N we don't know, so write N only, divided by volume, that is 1000. 1000 means what is ml, but here it is in liters, so that becomes 1000 ml is equal to 1 liter, so write 1 here. Okay, now just crisscross here, so this becomes N is equal to 3 into 1, so answer is 3. Okay, the answer is 3. Yeah, the answer is third one, the third option, answer is 3, so tick the 3. Understood this one? So very simple, the number of, see, here nothing but a molarity formula you need. Molarity is equal to number of moles of solute by volume of the solution, right? So here molarity is given 3, already it is given 3 molar, means molarity. Number of moles we need to calculate, and volume of the solution is given 1000 ml. So 1000 ml can be written as 1 liter. So just put here 1. So 3 is equal to n by 1. When 1 bring here, so 3 into 1, so that n is equal to 3. 3 is the right answer. Okay. Finished. Okay, then go to the next one. Next one question is, among the following, the best which describe the concentration of solution formed by dissolving 4 grams of sodium hydroxide in 1 kg of water. Okay, so here two things are there, students. One is sodium hydroxide, that is NaOH, and the second one is water, that is H2O. Here sodium hydroxide, how many grams are there? 4 grams of sodium hydroxide, right? And is dissolved in 1 kg of water. So water is 1 kg, right? So 4 kg dissolved in 1 kg. So what we can write? Okay, 4 grams dissolved in 1 kg. Right? So then what happens here? It becomes 4 here grams and its kg is going up. So kg to the power of -1 if you think. Okay. So this might be one of the option. But here it is not there. Here 4 grams per liter is given. But in the question it's given kg. So the first option is wrong. Now then go to the second option. Okay. Then you see here, we take here solute is in grams, solvent in kgs. So then best formula is molality. What is the best formula? Molality. Molality. Molality is equal to what? Number of moles of solute. Number of moles of solute by volume of solvent in liters. Sorry, in kgs. Molality. This is our formula. Okay, molality. So, first we need to find the number of moles of solute. Number of moles of solute, just now in the previous slide, you given the formula number of moles of mole is equal to what? Weight by molecular weight. Weight by molecular weight. So here you see now, weight by number of moles of solute, we are finding this one, right? So number of moles of solute is equal to N is equal to weight by molecular weight, right? So weight is given 4 grams here, so write to 4. By now we want molecular weight of the sodium hydroxide. So just now I told you that molecular weight, how can you find? Just adding sum of the atomic masses. Sum means what? Addition. Addition of atomic masses of all the elements. So here sodium hydroxide, sodium Na, hydroxide 1 O, 1 hydrogen. So 1 sodium is there. Sodium atomic mass is 23 plus oxygen atomic mass is 16 plus hydrogen atomic mass is 1. Now add, say the what is the value? Sodium is how much? Sodium, I am writing here, sodium atomic weight is 23. Oxygen atomic weight, see, 1 oxygen is there, oxygen is 16 and 1 hydrogen is 1. Now add total, how much you got? 40, correct? 3 plus 6, 9 plus 1, 0, 1, okay, 40. So I got 40 here. Now molecular weight of sodium hydroxide is 40, 4 by 40, right? So 4 ones are 4 tens are, so that's equal to 1 by 10. 1 by 10 is equal to 0.1. How much I get? 0.1. Is this clear? So now I'll write in the number of moles of solute place 0.1 divided by what is given the next term? 1 kg of water. So 1 kg of water is given. So volume of the water, sorry, mass of the water should be there here. mass of solvent is given 1 kg. So 0.1 by 1 is equal to 0.1, and this is called what? Molarity. So molarity is denoted by small m. So right option is third option 0.1. Third option 0.1. I understood. Very simple problem. So see here, 4 grams of sodium hydroxide is dissolved in 1 kg of water. Okay. So first you have to check that where we get the grams of solute in grams and solvent in mass. So we check that, if that's what I said you to read the definitions perfectly, right? In the definition of molarity, what is there? The number of moles of solute present in 1 kg of a solvent, right? So 1 kg of solvent, so you are getting kgs in the molarity. So you write the molarity formula. Molarity formula is what? Number of moles of solute by mass of solvent in kgs. So number of moles of solute, how can you find? Weight by molecular weight. Weight is given 4 grams in the problem, and molecular weight you need to calculate. Okay, so you need to calculate, that is the sodium hydroxide is NaOH. Na is 23 sodium atomic weights, and oxygen 16, hydrogen 1, so you will get 40, 4 by 40, 1 by 10. So that's 0.1, 0.1 by mass is given 1 kg over. So 0.1. So students, you see here, very important thing what you need to remember is, you have to learn at least first 20 elements atomic masses. This is very important. You have to learn first 20 elements atomic masses. Okay, and a few molecular masses also you have to learn. I will explain later. Okay. Now last and final one you see here. What is the normality of the solution containing 35 grams of potassium hydroxide dissolved in sufficient water to make 400 ml of solution? So here this problem looking like little big. Okay, no problem. So what is the normality? So you need to calculate the normality. So write N is question mark. That's the first thing is done. And solution 35 grams of potassium hydroxide. So weight is given 35 grams. Okay, of what? Potassium hydroxide. So we can write potassium hydroxide formula is KOH. Okay, and then what is given? Dissolved in sufficient water to make the 400 ml of solution. So volume of solution is given, V is equal to 400 ml. And just now I told you that how to calculate the molecular weight. Molecular weight of potassium. Potassium is 39 plus oxygen is 16 plus hydrogen is 1. So 1 plus 39, 40 plus 16, 56. So you will get molecular weight 56. Okay, and then what you need to do? You need to write the formula of normality. Normality is equal to gram equivalent weight, number of gram equivalent weight, number of gram equivalents, okay, by volume of solution in liters. Volume of solution in liters, right? So here number of gram equivalents, how can you find here? Okay, number of gram equivalent, we can find that molecular mass or molecular weight by its it is a salt, sorry, base. So acidity. Okay, this you will learn in the future classes, is equal to 56 by 1. You will get to 56. Okay. Then weight is equal to 35. So now substituting the normality formula, that is 35 by 56 into volume. Volume is given how much? 400. So you write 1000 by 400. Okay. So this way you need to calculate, students. Weight is given 35. So 35 correct only, divided by potassium hydroxide, K is 39. Oxygen is 16, hydrogen is 1, so 10, 16, 1, 56, so we are writing 56 correct only, into 400 ml is given, 400 and 1000, 2 zeros cancel, 2 2s are 2 5s are cancel, 5 1s are 5 7s are cancel, and 2 ones are 2, 28 is a cancel, 7 ones are 7, 4s are cancel. That's all, students. So 1 by 4 only, that is get 0.25, correct only. Okay, answer should be 0.25, but there is 0. No, it's not given. So 0.56 is given. So answer is wrong there. So the answer is 0.25 normal. That is the answer. Okay. So here, student, this chapter involves so many calculations. For that, I said, you are in the 9th class. So in the 3rd chapter of 9th class, atoms and molecules, you have the mole concept. So to understand the mole concept, first you need to learn the atomic weights of 20 elements, which are already I have given. And so these you have to learn. Based on that, you need to practice the first molecular weights. And after calculating the molecular weights, number of moles can be calculated by weight by molecular weight. Okay, so this number of moles, if you know, you can solve any problem like molarity, mole fraction, normality, and molarity. These are the most important problems actually which you asked in the main IIT also. So that's what these 4 you need to practice. Okay, so what are the problems I said? That problems you practice, and next exercise problems also you try to solve it. The remaining problems we can do it in the next class. Or if you are done, then we go to the next synopsis. Okay, so with this we stop for today.